Hello everyone, this lesson we're going to talk about multi-tab transformer calculations. So we're going to review the single-phase multi-tab calculation first. Here's a multi-tab transformer. Primary side, I have a 95% tab, 100% tab, and 105% tab. Secondary side, one winding. The transformer is rated 2400 volts to 120 volts. So based on the rating, I can find out the ratio is 20:1. Then the question asks you, if 2500 volts apply on 105% tab, what's going to be the secondary voltage? You learned this in second year. We're just going to give you a quick review. So here I'm going to show you two different methods you can find that. First one, because they gave us multi-tab, they tell us what's the voltage applied. We can find out for that voltage applied on that tab there, what's going to be the new ratio. Because it's applied on 105% tab, the original is 20:1 ratio. 20 times 105 give me 21:1 new ratio. So I can use the new ratio to find out the secondary voltage. The secondary voltage is going to be the primary applied voltage over the new ratio. So 2500 volts over new ratio 21. The secondary voltage will be 119.05 volts. So that's the first method. I'm going to show you the second method. For that 2500 volts apply to 105% tab, I can find out what's the voltage going to be on there on 100% tab. So find out the proportional voltage on the 100% tab. 2500 volt apply on 105% tab equal to the voltage I'm going to find out over 100% tab. So cross multiply that proportion. Voltage is going to be 2380.95 volts on 100% tab. Now use the original transformer ratio, 2380.95 volts over the original ratio 20, give me 119.05 volts. So you can see, different method, I can find out same voltage on the secondary side. So that's the review you did. You learned this in second year. Now we're going to do in third year. So I give you a three-phase multi-tab transformer down here. Here's my connection. The primary side, I put Y connected, and I'm using 95% tab on the primary side. Secondary side, I use a delta connection. So the supply is 4150 volts, three-phase. That's my line voltage on the primary side. Each transformer is rated 2400 volts to 240 volts. So from this two voltage, I find out the ratio is going to be 10:1. Now, the primary line voltage is 4150 because of Y connection. I have to find out the phase voltage. The phase voltage is going to be line voltage divided by root 3. So 4150 divided by root 3 give me 2396.1 volts. If I'm using the same thing on method 1 you learned before, new ratio going to be the old ratio 10:1 times 95%. The ratio becomes 9.5:1. So the secondary phase voltage, the supply voltage on the primary side, phase voltage divided by the new ratio, give me 252.2 volts. Secondary side is delta connected. So line voltage equal to the phase voltage. So the line voltage on secondary side going to be 252.2 volts. I also can, by using the method 2 to find out what going to be the voltage on 100% tab. So that's my phase voltage on 95% tab. To find out the voltage on 100% tab, use the proportion. I find out on 100% tab, the voltage will equal to 2522 volts. So with this 100% tab voltage, use the old ratio and find out, okay, secondary phase voltage, 252.2 volts. Same for my line voltage, 252.2 volts. So here's the calculation for multi-type transformer. I reviewed a single phase one. I gave you example on 3-phase one. So here I give you a connection in delta. The same thing gonna be for Y. As long as you find out the secondary phase voltage, the line voltage is gonna based on if it's delta connected or Y connected. So if you have any question, you can connect us online or send us emails.